Okay, in this video I want to do an example where you have to use integration by parts twice on the problem. So the problem that I'm going to attempt to integrate here is going to be the quantity ln of x squared. And just to remind you, the integration by parts formula, it says the integral of u dv equals uv minus the integral of v du. I've got some other more basic videos on integration by parts, so this might not be the best one if this is the first one you're looking at, but just something a little more complicated for those of you that would like to see it. So again, we have to pick u and we have to pick dv. Again, to go from u, we just simply take the derivative to get to our du portion, and to get v, we have to, after we pick dv, we'll have to integrate. Okay, well, I'm going to stick an extra 1 in here. There's not a lot of stuff to really pick for the u portion. I mean, you could either pick it to be the 1, or you could pick it to be, I guess you could pick it to be a single ln of x, or we could also pick it to be everything. And I'm going to pick u to be ln of x quantity squared. Okay, so that means by default my dv is going to be the 1 dx term. Well, if I take the derivative, let me give myself a little more room here. I'm going to have to use the chain rule on the derivative. It says I'll get 2 times the natural logarithm of x to the first power, and then it says I multiply that by 1 over x dx. Okay, if v is 1 dx, when I integrate, I'll simply get x. Okay, so it says I need to fill in all this stuff. Okay, so it says I get u times v, so I'll get ln of x squared times x, so there's my u times my v term, minus the integral of v, which is x, times du, which is going to be 2 times ln of x times 1 over x dx. And what we're going to do is we need to simplify down the right hand, the new integral. So we can pull the 2 out front. Notice that the x times 1 over x, these terms would simply cancel out. And then all we're left with now is the integral of ln of x dx. And if you think about, where you were at in the first step we had ln of x quantity squared, and now I've bumped it down to ln of x to the first power. So that certainly makes me feel like we're going the correct direction here, that things are working out. Let's see, so, okay, technically I probably shouldn't use u and dv again. It's kind of bad notation, but I'm going to anyway. So I've got to pick u, from that I'll get du, I've got to pick dv, from that I'll get v. Well, why not pick things like we did before? I'm going to let u be the ln of x stuff. The derivative of that will be 1 over x dx. I'll let dv again simply be the, you can think about there as being a 1 dx in there. I could have left the 2 in, it doesn't matter. Let's see, I'll let dv be 1 dx, and the v term then when I integrate will simply be x. Okay, so this is where we're going to have to be a little careful with our, just with our bookkeeping here. Make sure nothing crazy happens. So I'm going to put my new integral that I'm going to use integration by parts on in the blue brackets, because I'm going to have to expand all that out. So it says we get, I'm going to write the x first here. So we get x times ln of x quantity squared minus 2 times, and now I've got to use my integration by parts formula on all of this stuff. Okay, so it says we get u times v. Again, the u term is now ln of x. My v is x, so I'm going to write it as x ln of x. So there's my uv minus the integral of v, which is x, times du, which is 1 over x dx. But, well, we can simply cancel out the x times 1 over x. Those will cancel, and we'll just be left with the integral of 1 dx. Okay, so now we're pretty much there. We've almost got our answer at this point. All I really need to do is just clean it up here a little bit. Let me see if I can squeeze it in just a little bit more here. Okay, so it says the x ln of x squared term from the beginning, it's still just kind of chilling out there. And I'm going to do a bunch of things at once here just to clean it all up. So this first part inside the brackets we're done with, so I'm going to distribute the negative 2 and get negative 2x times ln of x. Notice if I distribute the negative 2 to the minus, I'll get positive 2. Well, if I integrate 1, I'll get simply an x term. And that's now everything has been integrated. I integrated the last part, I distributed the negative 2 to it, there's no more integral signs in there, so we'll tack on our plus c, and that will be our final answer. So integration by parts twice, just kind of being careful with things, nothing too crazy. Again, I think the key thing to recognize here is that, compare what you started with to what you got after the first time. Well, after the first time, it bumped down to ln of x to the first power. And again, that suggests to me that if I keep doing it, eventually the ln of x's will hopefully go away, which is exactly what did happen. Alright, I hope this extra example helps. Just shoot me an email if there's anything you got questions about, and I will try to make sense out of them.